Welcome to this lecture. So now inside our application we are registering faces, and that is one important part of our face recognition system. And the second important part is recognizing those faces after registering them. And now in this lecture we are going to start that process. So for now inside our application, user can choose or capture image in this registration screen, and then he can register that face in the database. But now when he will gonna click on this recognize button and move to the screen, and here he will gonna choose or capture any other image like this image of Lionel Messi. Then after selecting the image, we should be able to tell him that Lionel Messi is present in the following image. And the reason is we have registered the face of Lionel Messi inside our application inside previous lectures. So now on this recognition screen we should be able to recognize some other face or some other picture of Lionel Messi, and we are going to do that thing inside this lecture. So here in this recognition screen, once the user will gonna choose or capture the image, we need to detect the face present in the image, and then we need to crop that face. And after cropping that face, we need to pass that crop face to our face recognition model and get the embedding for that face. And after getting the embedding, we need to compare the embedding for this face of Lionel Messi with all the registered faces. And then we need to find that where the distance or the difference between the embedding of this face and the embedding of registered face is minimum. Because where the distance or the difference between two embedding is minimum, that will be our recognition. So in other words, we are going to compare the embedding of this face with the embedding of already registered faces, and where the difference or the distance between two embedding is minimum, we will consider that registered face as our recognition. So hopefully you are getting the point. So as from this explanation, you can see that we need to perform almost all the things which we are doing in this registration screen. That we need to detect the faces and then crop them and then pass them to our face recognition model and get the embedding. But in this registration screen, after getting the embedding, we are showing a dialog to the user. But now on this recognition screen, we don't need to do that. But instead, we are going to compare that embedding with the embedding of registered faces. So here in this recognition screen, we are going to perform 90% of the same tasks which we are doing on this registration screen. So in this recognition dot which is the code file for this screen, we can simply copy the code of this registration screen dot. So what you can do is to copy all the code here, and then you can simply paste it inside this recognition screen dot. So you can remove the earlier code and paste the new code here. And after doing that, you can simply change this registration screen with the recognition screen. So recognition screen, and here you can correct the spelling, and then you can simply copy it and paste it here, here and here. And after doing that, we have added the same code which we did inside our registration screen inside this recognition screen. And now inside this code, we need to make some changes. And the first change is we need to comment this line show face registration dialog, because this is our recognition screen and here we are not going to show that face registration dialog. But instead, here after passing the cropped face to our face recognition model and getting the embedding for that face, we are going to compare that embedding with the embedding of already registered faces. So now we need to do that thing here. So we need to compare the embedding which is stored inside this recognition object with the embedding of already registered faces, and then we need to find such registered face for which the embedding difference between two faces is minimum, and that registered face will be our recognition. And in case of this image, when we are going to compare the embedding of this face with the registered faces, then obviously the difference between the embedding embedding of this face and the embedding of registered Messi face will be minimum. So we can recognize that Lionel Messi is present in the following image. So we need to do that thing. But in actual, when we are calling this recognizer.recognize method, in this method we are already performing that thing. So when this method will be called, we are passing this cropped face to our face recognition model and getting the embedding. But in this method, after getting the embedding, we are also comparing that embedding with the embedding of already registered faces. And then we are finding the registered face for which the difference between two embedding is minimum, and we are storing the name of that registered face in the name property of this recognition object, and the distance or the difference between the embedding of this face and the embedding of that registered face is also stored in the distance property of this recognition object. So in other words, inside this recognize method, apart from passing input to the model and getting the embedding, we are also performing face recognition. So here in this recognition object, we are actually getting the name of the recognized face as well. And you can simply print the name property of this recognition object and you can confirm this thing. Like here we can simply print recognized face. And then you can show this recognition dot name here, and after doing that you can simply hot reload the application, and then here you can go to the recognize screen and select the image. Like we are going to select this image of Lionel Messi. So now you can see we got the image here and we got a rectangle around that face, but here we did not get the dialog because we have commented that line. But in the console you should be able to see the name of the recognized face. So there you can see we got this message, recognized faces is equal to Messi, and the reason is we are printing that value here. So it means that our application is working correctly and we are able to recognize Lionel Messi here. And the main reason is in this recognize method, after getting the embedding for this crop face, we are comparing it with the embedding of registered faces, and then we are finding that the registered face of Messi is most close to this face. So we are returning the name and the distance in this recognition object, and then we are printing the name here. Similarly, let's select some image of Ronaldo like this image. And here when you will scroll down, you can see the recognized faces is equal to Ronaldo because we have selected the picture of Cristiano Ronaldo here. So it means that our application is working correctly. But here it is very important to understand that point, that inside this method, apart from passing input to the model and getting the output, we are also comparing the embedding for this face with the embedding of already registered faces. And where the difference between two embedding is minimum, we are considering that registered face as our recognition. And we are going to look at all this code which is present in this recognize method inside our upcoming lecture. So there this thing will also be clear for you. But for now, inside our application we are performing face recognition and we are showing the name of the recognized person in the console. But in actual we need to show the name of the recognized person along with the rectangle on screen. So how we are going to do that thing?